Alrighty, welcome webinar participants. Today we have Mr. Ismail from TechWorks in Amman. Mr. Ismail, thank you very much for joining us on
Not
today's
at all, it's my pleasure.
Thanks. Would you just give us a brief introduction of who you are and what you do at TechWorks?
Sure. My name is Ismail Hakki. I'm the director at TechWorks. TechWorks is an initiative under the Crown Prince Foundation, or CPF. It's a digital fabrication lab, or also known as Fab Labs across the world. We're part of the Fab Foundation and the Fab Lab network, which includes approximately 1,800 Fab Labs across the globe. Basically what a Fab Lab is a facility where we transform a digital model into a tangible model through various types of machinery. The most notorious, let's say, digital fabrication equipment is our 3D printers. But 3D printers are like a microwave in a kitchen. They're just one tool for digital fabrication. So a Fab Lab usually includes a number of different tools. Over and above 3D printers, there are usually laser cutters, CNC machining, vinyl cutters, PCB engravers, or electronic stations in general. And the function of a Fab Lab, or the main, one of the main purposes or goals of a Fab Lab is rapid prototyping. So it's quick transformation from design to product, quick iterations. You're always close to your product. It's part of the makers movement, which is actually a movement that empowers the control of manufacturing, empowers the designer to be in control of the manufacturing. So I don't want to go into too much detail, but it basically transforms a consumer society to a maker society, or a linear economy into a circular economy. A linear economy, and again, I don't know how much detail I should be getting into here, but a linear economy basically is, as it says, it's a linear flow of events. So there could be raw material extraction in a certain country that is shipped to another country for manufacturing, and then a third country for assembly, and a lot of energy, time, resources, CO2 emissions are consumed in this process. It's a very long process, and there's a lot of waste throughout it. What we do with digital fabrication, and why we call it a circular economy, is the whole production cycle is based on a digital file. So if somebody has a design in Japan, he can just email me the file and I can produce it locally, and eliminating the whole linear process, so to speak. It has digital fabrication has a lot of other benefits as well. One which seems to be undermined, in my opinion, is the virtual inventory. So basically, I'm only producing what I need. I don't have a stock of merchandise or materials that are just taking up space waiting to be used. I need 3 models. I'll print out or fabricate 3 models, and I'll have the digital file, which in many ways saves on cost, space, logistics, materials, environment, all of the above.
So kind of going off that last piece, in this time of COVID-19, we see a lot of shortages and a lot of need for a lot of medical devices. What is TechWorks doing to meet that need? And what are some of the products that you might be producing in the lab? What are you communicating with any of the hospitals or medical associations in the area to fill that need for stuff like face masks, face shields, even ventilators? What are some of the things that TechWorks is producing to meet the need in the area in Jordan?
Yeah, we are in touch with several different authorities, whether governmental or medical authorities in Jordan. And what we're trying to do is assess the needs, because at the end of the day, we want to produce items that are needed or that are in shortage, rather than producing what we think they need. So we classified the medical needs, or let's say the medical equipment that we are able to provide on a certain level of fabrication, into three main parts. One is PPE, which are the personal protective equipment. And these are a variety of equipment, from face shields to masks, to gowns, any medical equipment that the doctors and nurses or the medical staff can use directly or on the front line. The second category is the what we call an Ambu Bag Actuator. Ambu bags are I'm sure you've seen them before. They're that bag that you squeeze manually. They're usually used in resuscitation and so on. And the third level of is actual mechanical ventilators, which are very high-end machines. And what we decided to do, knowing our capacity and our capability as a Fab Lab, is not to embark on the third type of ventilators, because they are very sophisticated. They're very sensitive pieces of machinery, and Neil Gershenfeld, the founder of the Fab Lab network, actually sent out a message saying, just cautioning Fab Labs that no ventilator is better than a bad ventilator. So we think, and through our research, medical equipment take 12 to 18 months in testing and validation before they're ever put on a person, let alone a patient with respiratory illness or a condition. So what we focused on were the PPEs, and I have a PowerPoint presentation I can just show you and explain at the same time. So can you see the screen?
Yep.
Okay, so so this is a mask that we've done. We've cut it out of acrylic. We did not go with 3D printing with this because of time constraints. It's a lot faster to produce large quantities of masks. Having said that, TechWorks as a Fab Lab is not a production facility. Although we are feasible on low volume productions. These face masks we can produce in low volumes. Low volumes, I mean, thousands, but not tens of thousands. So they're basically cut out of acrylic. We have a sponge-like, I don't know, cushioning there on the forehead to make it a bit more comfortable. And the sheets we use are PVC sheets, which we cut using a laser cutter, which we shouldn't. PVC apparently, when cut with a laser cutter, emits a lot of toxic fumes that are not only harmful to the user, but also to the machine. It corrodes the lens and etc. So we're kind of looking into different types of material. This is how the mask, the face shield is worn. So it completely protects the medical staff, especially during intubation, because when you put a coronavirus patient on a ventilator, it's usually an intubation process where there's a tube that goes down the esophagus. And there's the mask again. So this is all part of the PPE equipment. This is a two-way valve. So basically, we printed this on a 3D printer. This is PLA. Again, it's just a prototype for production. Different materials should be considered for this. Something that is both medically approved and something that can give a tighter seal. Sanad, I'm sure, as you know, PLA sometimes leaks, especially with air. So it's not the ideal material, but this is the idea. And this is how they would be used on ventilators. So
cool.
again, this is not ideal because you have two people on the same ventilator, therefore assuming that all the variables are the same with these two people. But then again, this is not standard medical practice. This is emergency situations. So even though it's not the best practice in medicine, in life or death emergency situation, it's considered acceptable on some level. And this is the a prototype for so this is not a ventilator. We are very careful about calling it that. This is an Ambu Bag Actuator. So you can see the Ambu Bag in green over there. And basically what it does is so the blue glove is mimicking the lungs. And we have a dimmer switch that, and that motor you see there is a windshield wiper motor, which we've attached to the camshaft. So basically there are three parameters that we're controlling here. One is the BPM, or breaths per minute, and we control that through a dimmer switch. And that ranges from 0 to 32 beats per minute. Breaths per minute. We also have, if you can see the camshafts up there, they're different sizes. So the shape of the camshaft gives two different parameters. One is volume. So you're controlling the amount of air that's being pumped into the lungs. And the other, which is actually the shape or the curve, is called the IE ratio, which is the inspiration and exhalation ratio, which is important in COVID cases. This is another video showing the same machine. Very little was 3D printed with this. It was mostly cut with acrylic, and what makes this device viable is a number of reasons. Most importantly, it's been accepted by the Spanish Agency for Medicine and Medical Devices as an emergency ventilator. And the other thing is its simplicity. So it's very easy to produce in large volumes. So this is what they call the oxygen M, with M standing for maker. So it's the maker model. The maker model isn't the accepted model. Can you still see my screen?
Yep.
Can you see? Yeah. So this is the oxygen P model. It's exactly the same mechanism, but they've changed the material to be a bit more, so a medical grade material. So you don't have any bacteria growing on the surfaces. And let me show you a quick video for it, because this machine has actually been installed and is currently being used on patients in.
So how many of those have you produced
so we've done one prototype, and we are currently working with CADB to manufacture this one.
Well, this is super interesting, Mr. Ismail. If I may ask, are you collaborating with other fab labs?
Yes, thank you for asking that. Well, we kind of pride ourselves in the Fab Lab network as being an open source collaborative platform. So what we did was, this design is open source, which means it's accessible for anybody to download and use or reproduce. Although we had to change the design to work with local material and local standards, because each country kind of has a bit of a difference between the available material and such. But so what we did was we invited Shamal Start, Fab Lab Irbid, which are our partners, or
your sister lab. Yeah.
Well, our colleagues, actually. They're our colleagues in the Fab Lab network. And what we wanted to do was a number of things with them, obviously collaborating on this project, but we wanted to show, because we kind of hear this a lot, like, oh, they're your competitors. We wanted to show everybody that, you know, the culture that we and the ecosystem that we belong to is a collaborative one. It's not competition. It's about working together for the greater good. And that's what we did on this project. We invited Shamal Start. We knew they couldn't access their lab in Irbid, and invited them to be part of the team and collaborate with us on this project.
Very cool.
Great.
Yeah.
So I think kind of wrapping things up with just a final few questions. How is open source? Open source is definitely big in the Fab Lab community. How has open source helped you kind of break through the barriers of production, especially in this time of need? What are some of the benefits right now of open source?
Well, thank you. Well, you know, this whole pandemic situation kind of shed a whole new light on how important open source is.
Mm-hmm.
It basically helped us cut corners. So basically what open source does is the whole community builds on each other's experience. So basically when you jump in on a project, you're already building on a cumulative experience of the network that's involved in the project or has worked on it. So basically, in a nutshell, I mean, that's what the benefit of open source was to us in this specific situation. We just downloaded the designs and did the adjustments that needed to be done. And we went through the design learning curve or the production learning curve through doing. Because even though it's an open source design and it's accessible to anybody, you still need some sort of know-how or engineering sense kind of while you're building it, and some also design skills and electronics production skills and whatnot. But I think this showed how valuable the open source community is in a situation like this, because other devices that are not open source and people are trying to reverse it are just haven't been cracked. People are not there yet. Although a lot of people are working on high-end ventilators, but I mean, it could be next week that they have a breakthrough, or it could be 6 months from now and they're still in the R&D phase. So there's no telling when or where people will reach, you know, achieve let's say closed source or encrypted devices. But with open source, you're just cutting corners. You're just going straight to production, more or less.
Great.
Well, if I may ask one last question, is what do you think our students at home can help with?
Wow, that's a big question. Well, first off, the biggest help they can do is stay at home, obviously. With today's world is connected, so there are many ways where they can work from home and offer their ideas, feedback, designs, whatever it is, through communications. So research is very important. I would say don't dive in there just to do anything. Do your research. A lot of what's being done is what we call publicity stunts. So it might seem like a nice idea, but when it comes down to it, there are a lot of things that haven't been considered. An example would be like some of the 3D printed masks you would see. I mean, it's a great design, but from a practical point of view, you need to think about the situational needs. So let's say you need to manufacture it in large quantities. 3D printing takes a long time.
Mm-hmm.
I would not recommend to 3D print anything unless you had to. Other machines are a lot faster. Also the material you're using. Research what's applicable to the situation. Some material might be toxic and might work against the patient.
Okay.
So look into what's medical grade or food grade, and explore open source. There are so many resources out there. You just, I'm sure you've heard the saying, the world's at your fingertip. I mean, I'm sure you all know that it truly is. So you have all these open source designs. Do your research, look into the designs, fiddle around with them. If you have a 3D printer at home, try to print something out. Look at the best practices, what's going on in the world. Research filter material. Homemade filter material. There are a lot of articles out there. Everybody's focusing on the mask, but a mask without the right filter is pointless. It's useless. Yeah, I mean, I wish I was in high school with all these resources. When I was at that age, you have there's a lot of information out there, a lot you can do from home, and yeah.
Great. Well, thank you so much for your time, and we will put a link with the information about TechWorks and what you're doing there in the description below. Awesome. Well, thank you so much, and be well and stay safe.
Not at all. Thanks for having me. Thanks, Chris. Thanks, Sanad, and hope to see you guys soon. Stay safe. Thank you.
Thank you very much.
So once again, students, thank you very much for watching that interview. I hope you found it entertaining and also informative about how technology is starting to be used to help meet the need of medical practitioners, medical institutions like hospitals, and first responders. I think TechWorks is doing a great job helping meet that need, and we're looking forward to seeing their continued help in this matter. And that's where we're going to turn it over to you. We're wondering what you can do based off of what you heard from Mr. Ismail. What can you do to help, as far as using technology, to help mitigate the spread of the COVID-19 virus? What we've done is we put together a bunch of resources for you to look at in the resource tab below, or over to the side on the platform. And we want you to play around. We want you to play around with what Tinkercad designs there are, what both laser cutting and 3D printing stuff there is. Keep in mind that 3D printing does take a lot of time to produce very small things, for those who remember from the mini masters. So keep in mind about what you're doing, what you're using as far as resources go, how much you can produce, and play around with the design. See if you can actually improve upon the designs of these medical devices and such. With that, thank you once again, and let us know if you have any questions. You can always contact Mr. Sanad or me at our email addresses. And once again, thank you for watching.